Hi and Assalamualaikum everyone. My name is Sofia Alisa binti Muhammad Haide from Group 9. Today my group and I will be presenting our topic on chromatography for the subject CHM256 course. Joining me today are my group members Adani and Arya. So what is chromatography? Chromatography is a vital analytical technique that allows us to separate, identify and measure the individual components within complex mixtures. It works based on how substance move differently through two phases, a stationary phase like a paper or a column and a mobile phase like a solvent or gas, by providing accurate and efficient ways to analyze substance at the molecular scale. This method is extremely useful in science and industry. Its importance spans from fundamental research to industrial applications, making it a key tool in laboratories worldwide because different molecules travel at different speeds depending on how they interact with each phase, so we can physically separate and analyze each component.
Explanation on the application of chromatography.
Let's get into the theoretical background of chromatography. Chromatography is a method that mainly relies on the polarity, solubility, and intermolecular forces between the substance and the phases. As we know, each component in a mixture would interact differently between the two phases, which is the stationary and the mobile phase. The stationary phase, or the static part, is a porous solid or solid coated with liquid, fixed in place. It absorbs the components in the mixture while the solvent and sample move through it from separation. Next, mobile phase, or the moving part. Mobile phase moves through the stationary phase, carrying the mixture with it. It can be a gas, liquid, or supercritical fluid. It is because of the difference in their intermolecular attraction, it allows the components to move at different rates to separate over time. Additionally, some components in the mixture will be more attracted or absorbed towards the stationary phase and some towards the mobile phase. Partition versus adsorption. Partition chromatography is a process where the component of a mixture distribute themselves by dissolving between two immiscible liquid phases. It occurs when a liquid stationary phase is coated onto the surface of a solid support, allowing the solid to equilibrate between the stationary and mobile phases. The separation is driven by the difference in solubility of the solid in each liquid phase. Adsorption chromatography. The stationary phase is a solid on which the sample components are adsorbed. The components of the mixture selectively adhere to the surface of the finely divided solids, such as silica or alumina. The mobile phase can be a gas or liquid, and it flows through the stationary phase. The component interacts with the solid surface to varying degrees. This difference in adsorption strength causes the component to separate as they move through the system. Next, we will be talking about the methodology of chromatography. There are mainly two chromatography methods, which is planar and column chromatography. Let's talk about planar chromatography. The technique we use for the stationary phase is coated on a flat surface plane, and the type of plane should be paper chromatography, glass plate, thin layer chromatography. How it works: the sample mixture moves with the mobile phase, and the compound travels different distance based on their interaction with SP and MP, which is the stationary phase and mobile phase. Separation occurs as each components interact differently with the stationary phase. How we can use this? The RF value, or retention factor, is used to identify unknown substances. Next, let's talk about the column chromatography. It's a technique where separation occurs on a solid material called the stationary phase, or SP, which is packed inside a columnar tube. A liquid called the mobile phase, or MP, is then passed through the column either by gravity or pressure. The stationary phase is usually made of silica gel or alumina, while the mobile phase is either a pure solvent or a mix of solvents. This setup is a type of solid liquid chromatography. So how does it work? As the mixture flows through the column, its components move at different speeds. Each one interacts differently with the stationary phase, and that difference causes them to separate. Eventually, they come out of the column one by one, and we call this elution. What is it used for? It's useful for separating the parts of a mixture and identifying unknown substances and purifying compounds to get a clearer product.
Real-world example. Chromatography has many real-world uses. In medicine, it's used for detecting drug levels in blood, like in cases of paracetamol overdose, and for purifying vaccines or antibiotics using HPLC. In forensics, it helps identify illegal drugs found at crime scenes and is also used to analyze ink to match handwriting or printed documents. In the food industry, chromatography is used to test for pesticide residues in fruits and vegetable and to check food coloring or preservative in snacks. In environmental science, it monitors water pollution by detecting heavy metals or toxins, and it analyzes soil samples for contamination near factories. It's even used in sports to detect banned substances like steroids in athletes' urine during doping tests. Now, for the analysis, efficiency-wise, chromatography allows fast and accurate separation of mixtures. HPLC and GC methods are known for giving quick and precise results. The advantages are clear. It works on solids, liquids, and gases. It's also very sensitive, detecting even tiny amounts of substances. That's why it's widely used in labs and industries. However, there are limitations. It can be costly, especially with equipment like HPLC and GC, and it requires trained users. Plus, separating very similar compounds can sometimes be difficult. In short, chromatography has a huge impact in the real world. It's used in medicine for drug and blood testing, in forensics to identify substances, in the food industry to detect additives and pesticides, and in the environment to monitor pollution in water or soil.
In summary, chromatography stands out as a technique for separating and analyzing complex mixtures. The key idea is that each substance moves through a stationary medium at its own speed, allowing us to physically separate and analyze them. Its success is based on selective interaction between stationary phase and mobile phase, which allow molecules to be distinguished according to their unique characteristics. There are several types of chromatography techniques such as paper chromatography, which is simple and often used in schools or for quick tests. Whether in drug development, environmental testing or forensic science, chromatography's adaptability and precision have solidified its role as a fundamental analytical approach. While there are some challenges, continuous technological improvements ensure that chromatography remains an essential and evolving tool in scientific and industrial arenas. So that's all from us. Thank you for listening. Bye!